Hi, this is Karen O'Brien, and I have had a question from one of you guys about how to set up this NOAA Atlas rainfall map for your own project. So I'm going to hopefully show you how to do that now. So if you follow through these steps of setting up the hydrology on this little test project, you'll see that we use this rainfall raster to calculate the rainfall of the system. So you'll see here that has, well, I guess I don't actually show a picture of it, but there's a rainfall raster. You'll get to see it shortly. And let's go ahead and click this website right here, which is just Googling the NOAA Atlas 14. And this is kind of the first thing that pops up is this precipitation map. And you get these hydrologic units right here, or these locations that you can click, and they will give you precipitation estimates for your project area. So you can use this as, if you don't want to do spatially variable rainfall, that's fine. You don't have to. You can just do uniform rainfall, and then you just go find your storm and you find your 24 hours and you have a rainfall. You have a rainfall amount that you can use. You also have a, a confidence interval here as well. But if you would rather if you have a bigger watershed and you want to apply that spatial variable like technique, it's pretty simple. You can just grab your 24-hour map and just submit this, and it's going to download the entire Southwest map. I've already done it a couple of times, so I wanted to show you that it looks like this when you get it. It's just an ASCII file. So what you'll want to do is open up a blank QGIS, not your project QGIS, just a blank QGIS, and drag that map onto your, or drag that layer onto your map, and that should define your coordinate system. Once you drag that onto your map, you should get that coordinate system. And then I also took the, this is straight from the census website. It's just polygons of the states, and it's in the same coordinate system. So I downloaded one of these. Really, I don't know that it matters which one you download. I just got one of these, and then it was all of the states. So I just deleted out all the states except the one I was interested in. Now, of course, if you've got a watershed that crosses a state boundary, or even like a NOAA Atlas boundary, be careful about that. Now I have both of these overlaid on top of each other, and I'm going to use this one to clip the data out of this to just the data that I'm interested in. So that's fairly simple. If you just come over here to your processing toolbox, you can use the Saga tools. The super easy and fun tool to use is just this clipper raster with a polygon. Your input layer will be that raster. Your output or your polygon will be the polygon, and then you just click run. You don't do any save to or anything like that, just click run. And we'll just wait for that to finish, and I'll show you what that final result looks like. Don't click run again, just click close, it's finished. And then we'll turn these two off, and you'll see that we have just the Arizona data. Now, this data is not really ready yet because we need to convert it to the correct coordinate system. So the way to do that is to warp it and reproject it into the coordinate system that we want for our project. So if I right click and I click export, you can either use the reprojection tools or the reprojection tool warping tools over here, or you can just click right click the layer, save as. We want to save it as a GeoTIFF. I want to take it, sorry, I've done this a couple of times, just trying to get this down. Save it to the raster and click save, and it will, oh wait, I'm sorry, yeah, it's going to replace it, that's fine. But don't add it back to your map. You don't want that on your map because you just don't need it. And then make sure you set this to the correct coordinate system. That will be the coordinate system for your project. Lesson 1 is actually 2223, but if you're working in this central Arizona, you're working for the flood control district, you want your coordinate system to be 2868, not 2223. That one's kind of wrong. So Click OK, and that will write that data out to the map. Now so you can do that for all those different storm events, 10-year, 20-year, 50-year, 500-year. You can do that exact same process for all of those and get a single distinct raster for each of those storm events. Then you minimize this and you go to that. This is the data where this is my data. So here you see I have my Arizona polygon and I have my that raster that I just made. And then, so this is kind of like the first attempt. So show you that I loaded that raster into the map. You can see it right here. I'm just going to click on that. Well, let's do this. Let's take the one that I made, that -2, and pop it in here. And then let's zoom to that layer. And so you can see here that this is your raster for that rainfall data for your map. Now what I've done with it, I'm just going to remove this layer. What I've done with it is I have limited it to a certain color band. So I double clicked it and I put on a color band. Let's just say 3600 to 3750, and I'll click apply. And then you can see here that that's kind of way that they create the isohydal curves for your mapping projects. If you use those isohydal plots for other programs, that's kind of how they develop that. Actually, it's probably they start there and then they come back and they develop the raster from that data, would probably be what they're doing. And then this is not, so 3600 is 3.6 inches of rainfall to 3.75 inches of rainfall. And I'll just click OK. And let's zoom back into our area now. So if I just highlight that guy and zoom into that layer. Okay, so now you can see that our area doesn't have a lot of change in rainfall. It doesn't. It just has kind of a small, because it's a small area. So this is a big watershed model. You might see more appreciable change in rainfall, but we're not going to get too much. So what I do know though, what is important is that I can see that I have my reddest pixel is 3.744. So I can use that as my total storm event, 3.744. And then I take my rainfall distribution curve from this rainfall distribution curves that I have already given you in, let's get here to the documentation folder, and you see you have in your documentation folder several rainfall distributions, and you can build your own because these are really easy to build. So you can get these out of any hydrology manual for your county or whatever they do for you, or you can get these off of HMS or HEC1, or you can get these off of HydroCAD. So if you have HydroCAD, they have a lot of excellent rainfall distribution curves for locations all over the state. HydroCAD has that great data in there. So what we have here is 0 to 25 all the way to 24 hours. So that is a 15-minute interval of time in hours. And then over here is a distribution of like the percent total. So this goes from 0 to 1 because you're getting the percent total rainfall, and this is just a uniform distribution curve. So if you set it up without this the raster, every cell will get that 3.74 inches of rain at that distribution curve. Now, let's actually can click on that. No, it didn't give me the curve. That's okay. It doesn't matter. Now let's go to the raster, the rasterization process. So in order to convert this data to your grid, you need to interpolate it or warp it. So I'm going to remove this layer so that, let's see, remove, so that we don't lock it up, and we'll get it right back on here. So I'm going to click the button, and that is the no data value of the new raster we're going to make. And then in this case, I just put in the maximum of all no non-data pixels instead of the average, and I'll show you what happens and what that does here in a minute. And I click OK, and I click yes. to overwrite the data that's already in there because I've already done this. And then I click OK to close that. And now let's grab and let's see what that did. Okay, so I'm going to grab that data from the source data. Now, instead of that original data right here, let's just get rid of some of these because I get rid of that one and let me get rid of that one. Yeah, that's fine. Okay, so this was our original data. This is the interpolated or warped data. So this is the data for the whole state. This is the data warped to our project. And I'm going to drag that back into our map and we'll color it too so that it matches. And so what you get here is a square raster, but the pixels here are going to take the maximum of the pixels from our original map. So you can see here that the pixel here, let's get on this guy. This pixel should be 3.74. Sorry, this pixel is 3.74. This one is 3.72. And let's get back on this one. And this one is 3.72. So now what we do with this is we calculate the maximum value from this raster, which if you double click on it, you'll see that the maximum value is 3744. And then we will do just a simple percent calculation of the current cell over the maximum, gives you the percent of rainfall that that specific cell gets, okay? So let's take a quick look at this. If we now export this data as the rain.dat, so I'm just gonna just do the rainfall, and I'm just going to send it to that download folder. And now we have the rainfall data, and we have the rainfall data here. And I'm going to go ahead and just double click this and open it in Notepad. And you got your 3.744 right here. And this is telling you that you want to use the spatially variable rainfall. So you need these guys. So let's just take a quick look at these. And if we have a 0.990 for grid element number 5325, well, let's start with 1. Let's find some that are 1s. Okay, get down here and find a 1. So here's something with 100% rainfall, and it's this cell right here. And if I copy that, I'm going to just copy that and I'm going to put it in here. And I'm going to highlight it, and you'll see that, let's colorize this map too. We're going to colorize this map and single band pseudo color and invert the colors and classify. We don't need to clip the outer range values because we've already kind of done that by warping it. And click apply and OK. And now let's turn this one off. Okay, so now you see that we have our 3.744, 3.743. So all of the pixels in here are going to get 100% of that rainfall because, so let's see, let's go ahead and click in on that one. And you can see here that these cells, due to the 3 decimal places, if you take that value right here, is 3.743, and you put that over 3.744, 3.743, I'm doing it on my calculator, 3.743 divide 3.744, you get 0.9997, which will raise up to 1. Now let's get down here and do one of these guys. Let's grab this one. Now this one is grid, let's make sure we're on the right, grid element 2486. Actually, you can get any of those. So you can get any of those in there. And let's go ahead, 3324. Come back here to the rainfall data, Control F, 3324, and we click Find Next. And whoops, sorry, let's go in the other direction. And we get the 0.990. So let's grab that pixel value off of the raster. So I'll use the ID tool for that. That again, that's up here. And I'll click on that. And so that's 3.705. That's the lowest value. Let's just do 3705 divide 3744. And we get 0.9895, which again will come up to 3.990. So that's how this works. And of course, you'll see much more variation if your project is bigger. So that's the way that the system works. That's how we interpolate a spatially variable rainfall raster to the grid, and that is how you get the data. So I will post this to YouTube, and I'll add the links to the other data that I downloaded. And so you should be able to get everything in the description of the YouTube video.